Hello students, myself Shifa Shah from IT department, and we are going to continue the lecture series of microprocessor and microcontroller. In the last session, we have concluded our unit 5, that was area programming in C. Right? So up till now, we have studied the particular AVR, that is ATmega32 in assembly language as well as its C program. Now, from today's session, we are going to start with a new unit, that is unit 6, which is peripheral interfacing. Now, in this unit, we are going to interface various peripheral devices such as LCD, keyboard, ADC, DAC, sensor interfacing, stepper motor, right? So these are the various interfaces with ATmega32 we are going to study in this chapter. Now, in today's session, we are going to study on LCD interfacing, how to interface LCD with ATmega32. So let's start with the topic, that is LCD interface. Now, so basically, how does the LCD operation takes place in ATmega32? So in recent years, LCD is finding widespread using replacing LEDs, right? Either it is a 7-segment LED or multi-segment LED, and these are the various reasons, listed reasons for which the LCD is used right now comparison to LED. First, the declining price of LCDs. Then second, the ability to display numbers, characters, and graphics. This is in contrast to LEDs, which are limited to numbers and few characters. Then, incorporating to a refreshing controller into an LCD, they relieving the CPU of the task of refreshing the LCD. Right? And in contrast, the LED must be refreshed by the CPU to keep the displaying the data. Right? And last, the phase of programming for characters and graphics. So these are the various listed regions for which we are using the LCD, right, for interfacing rather than for 7-segment LED or multi-segment LEDs. Now, so what the LCD which we are going to connect with ATmega32 has this pin descriptions. So as you can see in this following table, the LCD is contains of 14-pin LCD, right? Whereas the first pin having is connected with the VSS, that is connected with the ground. The second pin, the second number pin is connected to VCC, which having the plus 5-volt power supply to switch on the LCD screen. Then third, that is VEE which is connected with the plus 5-volt power supply, but to adjust the contrast of the LCD screen. Then fourth, that is RS, which is the IO pin, which is the input pin, which is used for the register select. Right now, whenever register select, that is RS is equal to 0, at that particular time command register will be selected, and when RS is equal to 1, for that data register will be selected. Then fifth pin, that stands for RW, that is the read write pin, which is also an input pin. So whenever the RW is equal to 0, that is used for the write purpose, and when RW is equal to 1, that is equal to for the read purpose. Then sixth pin, that is E pin, which is again a IO pin, and that is used to enable the LCD. Right? And from 7 number pin to 14 number pin, it stands for DB0 to DB7. That is the data register where we can write or we can load the data which we need to display on the LCD screen. And as you can see, it is these pins are from DB0 to DB7, that is 8-bit pins. So 8-bit data can be sent simultaneously to this LCD pin. Right? So this is the 8-bit data bus. Now we will see how to interface LCD with ATmega32. So again, this while interfacing this ATmega32, as we have seen in the pin description, that the pin number 4 that stands for the RS pin, that is register select pin. So register select, whenever the register select will be equal to 0, we are used to write commands on the LCD screen. Right? So these are the various commands codes in hexadecimal for which the different commands are used to run the LCD screen. So the code 1, that is used for the clear display screen, then code 2, that is return home, then 4, that is decrement cursor, then it will shift the cursor to left, then 6th, that is increment cursor, that is shift cursor to right, then 5th, that is 5th number code, that is shift display right, 7, that is shift display left, and similarly A and C stands for the display of cursor on and display on cursor off. Then E, that is display on cursor blinking. F, that is display on cursor blinking. Then 10, that is shift cursor position to left. 14, that is shift cursor position to right. Then 18, that is shift the entire display to the left. And 1C stands for the shift the entire display to the right. Then 80, that is force cursor to the beginning of the first line. CO, that is force cursor to the beginning of the second line. Then 28, that is the two lines and 5 cross 7 matrix for which the 4-bit data can be sent simultaneously. And 38, that is 2 lines and again 5 cross 7 matrix, but data can be sent, that is a 8-bit. So these are the various code in hexadecimals for which we need to write the command on the LCD screen. So this will be used whenever we are interfacing the LCD with ATmega32. Now, next, that is how to interface the LCD with ATmega32. So as you can see on the screen, the LCD is connected with the AVR ATmega32. Right now, the 8-bit data which we need to transfer from controller to ATmega32 is connected to the port A of ATmega32. So PA0 to PA7 is connected to the 8-bit data bus of LCD, that is DB0 to DB7, that is D0 to D7. Then port B.0, B.1 and B.1, these 3 pins are connected to the register select, RW, that is read write purpose, and enabling the pin, right? And the VCC is connected to plus 5 volt, VSS is connected to ground, and VEE is connected with the potentiometer of 10K for adjusting the contrast. Right? So this is how we are connecting the interfacing the LCD with the ATmega32. Now, related to this interfacing, we will see its assembly programming as well as its C programming in detail. So, what are the different steps for sending a command as well as the data to the LCD? So, as you can see, to send the data and commands to the LCD, you should do the following steps. First, that is initialize the LCD. So we need to initialize the LCD screen. Then send any of the commands from the command table to the LCD. So different commands are given to this from the table, so in the form of code to the LCD screen to display to clear the display. Then to start to write the characters, we need to write display on cursor blinking. Then for 8-bit data, transferring the 8-bit data, we need to write the code, that is 38 in hexadecimal to the LCD. So these are the various commands which we will use while sending the before sending the character to the LCD. And last, whenever the command is sent to this LCD, after sending the command, we can send the data. So third was a point, that is send the character to the shown on the LCD. Right. So here, and the step 2 and step 3 can be used repeatedly while using the commands onto the LCD screen. Right. So basically, first step, that is initializing the LCD. So to initialize the LCD for 5 cross 7 matrix and 8-bit operations, the following command should be followed. First, that is 0x38 for receiving the 8-bit data, then 0x0e, that is display on cursor blinking, and 0x01, that is clear display screen. So these 3 commands we will write on the LCD screen and we will give to LCD screen for this particular command. Then next we will show how to send a command to the LCD. After power up, you should wait about 15. So we will generate a delay of 15 microseconds for before sending the initializing commands to the LCD. Right. So as we have said, the commands we using instructions. So before giving this command to the LCD, we will wait for 15 milliseconds, and after 15 milliseconds, we will give this commands to the LCD to initialize the LCD. And if the LCD initialize function is not the first function in your code, you can omit this delay, right? Then second step, that is sending commands to LCD. So to send any of the commands from the table to the LCD, make the RS and RW is equal to 0. So whenever the RS will be equal to 0, the command register will be selected, and when RW is equal to 0, that means the command will be will be given to the LCD screen. That means the write operation will be performed on the LCD screen, and put the command on the number of data pins, that is D0 to D7. Then send high to low pulse to the E pin to enable the internal latch of LCD. Notice that after each command, you should wait about 100 microseconds to the LCD module run the command, and clear the LCD and run the home commands are exceptions to this rule. Right? Then after the 0x01 and 0x02 command, you should wait for about 2 milliseconds. So here we need to generate 3 delay. First delay for 15 milliseconds for initializing the LCD. Second, for enabling the commands, we need to generate a delay of 100 microseconds. And after the clear screen has been applied using 0x01, we need to generate a delay of 2 milliseconds. So these three types of delay will be generated in the following program, right? And show the details of commands and the execution times. And third, last point, that is sending data to the LCD. So while sending the data to the LCD, what we need to do is we need to select the data register. So RS will be equal to 1, right? And read write will be equal to 0 for the write operation. Then put the data again on the D0 to D7 pin and send a high to low pulse to enable the LCD. Right? And again we need to call the 100 microseconds delay for the LCD module to write the data onto the screen. So these are the different steps for sending the data to the LCD. Now we will see a sample program for how to interface LCD and how to generate, send the data on the LCD screen. So here, as you can see on the screen, here the program shows how to send HI on the LCD using the 8-bit data. Right. So here, first of all, we have include m32def.inc library. Then we have used the directive.equ, that is equate. As we have studied in chapter 3, equate is a directive that is used for giving a user name respected with the different ports which we will use for the LCD. Right. So here port A has been given the name LCD underscore DPRT, then DDRA, then pin A. So various names has been given using the .eq directive. You can omit this and you can write directly port A, port B, DDRB, DDRC in the program itself if you don't want to write using this EQU. Right? That is up to you. Now, first, what we need to do is here we need to call, here we need to generate the delays. So here we need to use the stack for storing the addresses. So first step, that is to initialize the stack pointer. So with the help of LDI and out instruction, we will initialize the stack pointer using this LDI R21, high, that is the RAM and address, and we will send this particular address to the SPH. And similarly, we will use the low and we will send to the SPL. So this is the initializing of the stack. Right now, next what we need to do is we need to send, as we have seen in the interfacing diagram. So port A is used as the output port, right? And port B is also used as the output port. So here port A will be defined as the output A and port B will be defined as the output port. So here we will take 0xFF in register R21 with the help of LDI instruction, and we will give this 0xFF to DDRA as well as DDRB for making this port A and port B for as the output. Right? Then for generating, initializing, we need to give the delay of 2 milliseconds. Right? So this 2 milliseconds delay will be called using this call instruction. So call delay underscore 2 milliseconds. Now, next, that is second step, that we need to send the commands on the LCD. So here different commands, that is 38010E, that has been given to the command, and 0x06. So these are the 4 commands from the command table which we have seen. 38 will give the 8-bit data, will receive or transfer the 8-bit data. Then 0E, that means cursor on display on cursor blinking. So it is acceptable. Data can be accepted. Then 0x0, that is clear display screen, and 0x06, that means the cursor will cursor will shift to the left and will start the writing from the right side, right? So this way we can write the codes to that particular to the particular registers, and we can call the command write subroutine for writing the command, right? So here we have written call command write in all the command codes, right? Then next, what we need to, after command, third step was to send the data. So we will send the data, that is for here we need to send the data hi. So h will be sent into R16 and we will call the subroutine, that is data write, right? And last, that is I also will be sent and we will again call the data write, right? So this is how we will send the data. Now we will see the different subroutines, right? That is the 2 millisecond subroutine, then command write subroutine, data write, and what does the subroutine works on, right? So first, basically we will see that is the command write. So what does the command write will do? So the command is given to the port B, right? So first of all, on the port B, what we need to do is the command which we have written over that will be given to the port B, right? So it will be loaded on the port B. Then next, what we need to do here, we are using the command write. So register select will be equal to 0. So register select, that is connected with the PB0. So PB0, that will be cleared using CBI instruction. So CBI and then port B comma register select, that is 0. Then again read write is operation is given to the port PB1. So PB1 will be also cleared, right? So using SCBI instruction, as LCD is port B comma read write operation. And last, that is enabling. So we are enabling the LCD screen using the set bit instruction. So SBI, then enable port B comma E, right? So this way we can write the we can generate the command, right? And we will call the delay of 100 microseconds after sending the commands, right? Then that particular after the commands has been given to the LCD screen, then the screen will be again disabled. So enable will be again equal to clear using SCBI instruction, right? So this is the command write subroutine. Then second, that is the data write subroutine. So data write subroutine, what we need to, data has been given to the port A. So first of all, out port A comma R16. So whatever the data has been given in R16, that will be given on the port, loaded onto the port A. Then we need to select register select equal to 1 for data register. So using SPA instruction, we are using the SPA instruction. We are selecting the register select equal to 1. Then using this CBI instruction, we are making the read write operation equal to 0 for writing onto the LCD, and we are enabling the enable pin of LCD using the SBA instruction. Again, we will call the delay, and we will after sending one data, right, one character, we will switch off the LCD, that means disable the LCD using CBI instruction, and we will call again a delay of 100 microseconds, right? So this is the two subroutines, that is command write and data write. And here below you can see the three delays which we are using in the instruction. First, that is of 2 milliseconds, 100 microseconds, and that is a short delay, that is ST. So these three delays has been made as per our timing instructions, right? So this way we can send the data to the LCD using the program, assembly program. Now, similar program which we have written for the C language. So the delay which we have made for delay functions different which we have made for the assembly language, that particular delay, all the functions we will make using this void delay underscore microseconds, then delay LCD command write, and delay LCD data write. So these functions which we have written as a different subroutine in assembly language, that we will make in the C programming, right, using enabling instructions. Then we can for initializing the LCD, that means all the data or commands which we need to give, that will be given in this LCD, and the data which we need to print on this LCD, that has been given in main part, right? So this is the LCD programming in C, right? So that's all for today's session. Here we have completed first peripheral interfacing, that is LCD interfacing with ATmega32, and saw its sample program in assembly language as well as in C language. Right. In the next session, we are going to continue with the keyboard programming and keyboard interfacing with ATmega32. Right. So that's all for today's session. Thank you for